find the area between the polar curves r is equal to 2 times cosine theta and r is equal to cosine theta from theta is equal to 0 to theta is equal to 2 pi. So it asks us to find the area between the polar curves, this equation and this equation. So let's graph them. Actually graphing it by our hand, it's going to take way too long, okay? So I'm just gonna show you guys how it actually looks like. Just a preview, not specific. So this small circle, right, is the cosine theta. And the 2 cosine theta, let's just pretend that this length is z, okay? Then this is going to be 2z. And what 2 cosine theta is going to do is fill that 2z. Okay, so it's going to look like this. And the area, right? The area is this shaded portion. To solve this area, we need to be familiar with this triangle, okay? Let's call this angle theta, and this is r, and this is the length, okay? We approximate this curvy length as a straight line, okay? And let's say the theta is now 2 theta. So is now 2 theta. So which means the length, right, is now going to be 2L. And it's also the same when the radius, the r, so this is the r, but we have another r. What did it do? This is the L, and this is the L. So it turned to 2L, and this is the same angle, theta. Okay? So we can state that the L is proportional to the theta and the r. So the length is theta times radius. So let's put that right here. Okay, but when we have a triangle where this is the L is equal to theta times r, this is the theta and this is r, what is its area? That is equal to base times height times 1 over 2, which is going to be 1 over 2 times r squared theta, okay? And now, but the theta, right, it is not like chosen, okay? So this is our triangle, okay? This is our triangle. The theta, we don't like just set it, okay? It's not like chosen. So this is not just theta, okay? It is d theta. Okay, so we just differentiate this, which we just differentiate d theta, which then we get this. Okay, it is a changing degree. By how much? The integral from 2 pi to 0. 2 pi to 0. So this is our legit equation that we'll solve for. But as you guys know, that the r is equal to this and this. But what comes first? Okay, what I mean by that is, what's the length of this? That is the top minus bottom, okay? So let's have this first, which is the integral from 2 theta of 0. Wait, no, 0 to 2 theta. Pi, I'm sorry. The r is going to be 2 times cosine theta, which is also 1 over 2, can come in from because that's the coefficient, and when I square that, I get 4 cosine squared theta times d theta. And then a minus from the integral from 0 to 2 pi, yeah? And then, again, the 1 over 2 can come in front, and then the r now is going to be cosine squared theta. So cosine squared theta times d theta. Right here, I can do some grouping, just like what we do in algebra. So the 1 over 2 and the integral from 0 to 2 pi, right, can stay here. But 4 times cosine squared theta and just cosine squared theta, when you subtract that, we get 3 cosine squared theta times d theta. And the 3 can just come right there, which then we will have 3 over 2 times the integral from 0 to 2 pi of cosine squared theta d theta. Now I'm gonna show you guys something really cool that will save your life forever. Okay, this will get into your mind forever, and this will help you how to do the integral, okay, from any point to point of cosine squared theta or just sine theta. Okay, you don't have to waste your time knowing the cosine 2 theta is equal to, cosine squared theta minus sine squared theta, and then the sine squared theta plus cosine squared theta is equal to 1, and then you subtract whatever it is, and then yeah. So let's graph cosine squared theta, okay? And again, I'm not actually going to integral this and just draw a simple graph, and then the next time you guys won't even have to do it, So this is 2 pi, my bad. Then this is pi over 2, and this is 3 pi over 2. Wait, what? Yeah. And this is 1, this is minus 1. Let's graph cosine squared theta, okay? It's going to, just cosine theta will look like this. But since it's squared, everything is squared, okay? Everything is squared. So there is going to be no negative value. They're all gonna come up like this. But it won't have a sharp point edge right here, okay? Okay, it will actually bend earlier and then come down earlier. Okay, so it will look like this. And also it's the same thing as coming from pi over 2 to pi. And the same thing for pi to 3 pi over 2. And 3 pi over 2 to 2 pi. Okay, and let's draw a little box here. And if we separate into this, right? This area is equal to this area. Okay, so this curve, cuts it in half by curving, okay? And if this box, this area is equal to pi over 2, because that's pi over 2 times 1, but this area is equal to this area, that means this just one area is equal to pi over 4, okay? And we have another of pi over 4, another of pi over 4, and another pi over 4. So how many total of pi over 4 is that? That is equal to pi over 4 times 4, okay? There are 4 of pi over 4s. So let's get back to this. So we know that 3 over 2, that just stays the same. And the integral from 2 pi to 0, okay? 0 to 2 pi. We just found out the area of 0 to 2 pi of cosine squared theta. Pi over 4, pi over 4, pi over 4, pi over 4. And that is equal to pi over 4 times 4, which is equal to just pi. And it will come out to be the same result when it's sine squared x. Or theta, yeah, it doesn't matter which variables. So we just have found the area between the polar curves of this and this. And that's the answer we got. Unfortunately, the graph, we had to erase it. Well, anyways, thank you guys so much for watching my video. So see you guys in my next video. Bye.